What's up, team? Today we're factoring by using the greatest common factor learning target. It says I can factor a polynomial by finding its greatest common factor and undistributing. It's a very unmathy term that I'll explain here in a moment. So first things first, let's define what a greatest common factor is. So the greatest common factor, which we generally call our GCF, is the largest monomial that can be divided out of each term of a polynomial. I'm going to leave that definition up for a minute. So here's an example, 3x plus 6. We're going to look at each of these terms individually, and we're going to identify what is the biggest thing that we can divide out of both of those terms. So I'm noticing that only one of these terms has an x, so I cannot factor out an x, or I cannot divide out an x from both of these terms. But I'm noticing that 3 goes into 3x, and 3 also goes into positive 6. So we would say that our greatest common factor between these two terms is 3, because 3 goes into the first term and 3 goes into the second term. That's it. That's the greatest common factor. Let's look at the next one. 8x to the third power plus 12x. Well, the first thing I'm noticing here is that both of these terms have x's in them. That means that we can factor out at least one x. Well, this has one x, x to the first power, and this has x to the third power. They both have one x in common. There's 3 of them here, and there's only 1 here, but they both have 1. So we'll be able to factor out an x. So our greatest common factor is going to have an x in it. Let's see if that x has a coefficient. Now we're going to look at our coefficients, 8 and 12. Well, what is the biggest number that goes into both 8 and 12? I think it's going to be 4. 4 goes into 8 2 times, 4 goes into 12 3 times. So our greatest common factor for this binomial is 4x. Let's look at one slightly more complicated. We have 6x to the third power plus 2x squared minus 8x. Again, all of these have x's in them, so we're going to be able to take out at least one x. Let's see how many we can take out total. I see 3 x's here, I see 2 of them here, and I see 1 of them here. So they all have one x in common. So we can take out one x from all 3 of these terms. Now, both of these have 2 x's. You could factor out x squared from these 2 terms, but that doesn't matter because we have a trinomial here. Our greatest common factor needs to be able to be divided out of every single term that we have, whether it's just 2 terms or whether it's a bigger one that has, 10 terms or something wild, right? Okay, so we know we can factor out an x from each of these 3 terms. Let's now look at our coefficients. We have 6, we have 2, and we have negative 8. I think the biggest thing that goes into all 3 of these terms is 2. 2 goes into 6 3 times, 2 goes into 2 once, 2 goes into negative 8, negative 4 times. So our greatest common factor here is 2x. Okay, our last greatest common factor that we are seeking is over here. 10x to the 5th power plus 70x to the 4th power minus 150x to the 3rd power. Again, all of these have x's. Well, how many x's can we factor out or divide out of each of these terms? We could divide out 5 here, 4 here, and 3 here. Well, the greatest that we can divide out of all 3 of them is an x to the 3rd power. They all have an x to the 3rd power in there. Now, again, looking at our coefficients, 110, 70, and negative 150. I think the biggest thing we can take out of here is 10, because 10 goes into 110 11 times, 10 goes into 70 7 times, and 10 goes into 150 negative 15 times. Cool. 4 polynomials, 4 greatest common factors. Now, we haven't factored yet. We found the greatest common factor, but now we need to do what we're going to call undistribute. That's a very unmathy term. It's just the way that I see it, because we're used to distributing. So say that we have like 2 times, I don't know, x squared plus 3x plus 1. We all know we're going to take the 2, multiply it by each piece to get 2x squared plus 6x plus 2. Well, what we're doing now is we're flip-flopping this. We're starting with something that looks like this, identifying that 2 is the biggest piece that goes into each of these terms separately, and we're dividing it out. And our result is going to look like this with the parentheses. So for our particular examples, we already found the greatest common factor for each of them, which is great. That's step 1. Step 2 is our undistributing. Undistribute. So Again, it's a very unmathy term. If you were to go to another class and ask about undistributing, you may get looked at kind of funny. Technically, the word is factor, which we will use both of those interchangeably in this context. So undistribute, again, that's just the way that I view it because it makes more sense in my head. So if we're looking again at this first polynomial, 3x plus 6, and we're going to factor it, we've located our greatest common factor. So this thing is going to be 3 times the quantity of stuff. And now we need to fill in what's going to be in our parentheses. And to do that, we look at each term individually, divide out our greatest common factor, and write it down. So for this one, 3x divided by 3. 3x divided by 3 is just x. 6 divided by 3 is positive 2. We've undistributed this. To check our answer, we can do 3 times x to get 3x, 3 times 2 to get 6. These two expressions have the same exact value. Sometimes it's easier to work with something that looks like this. Sometimes it's easier to work with something like this. The purpose of this whole concept, of this whole lesson, is to equip you with the tools so that if you want to look at it like this, you can. If you want to look at it like this, you can. Because in larger, grander problems in future courses, sometimes, actually more often than not, it's easier to look at the factored form. Let's keep going. We're going to find all of the factored forms here. We found the greatest common factor. So we know that this is going to be 4x times some stuff in parentheses. So we're going to divide 4x out of each of these things. So let's take it in 2 pieces. First, the coefficient, which is the number, and then we'll look at the variable. So if we divide our 8 by 4, we get 2. If we divide our 12 by 4, we get 3, positive 3. But we can't forget about our x's. If we divide x cubed by x, well, that's going to be x squared. We just subtract 1 from the exponent. And then if we divide x by x, well, that's 1. So 3 times 1 is just 3. So this one's good. And again, we can check it. If we multiply the 4x back in, we get 8x to the third power plus 12 of x. Yep, and that matches. Cool. Moving on. Let's undistribute this one. We have 3 terms now. We're going to divide 2x out of each of these terms. The first one, 6 divided by 2 is 3. X to the third power divided by x is x squared. Didn't give myself enough room. The next one, 2 divided by 2 is 1, so I'm just not going to write it because it's implied. X squared divided by x is x. Lastly, negative 8 divided by 2 is negative 4. X divided by x, again, is 1. Don't need to write it because negative 4 times 1 is just 1. 1 to go. This will be our trickiest one. Maybe. We've identified our greatest common factor as 10x cubed. So let's factor out 10x cubed from this polynomial here. 110 divided by 10 is 11. X to the fifth divided by x to the third is x squared. 5 minus 3 is 2. Plus 70 divided by 10 is 7. X to the fourth divided by x to the third is just x. Minus 150 divided by 10 is 15. X to the third divided by x to the third is 1. So we don't need to write it because negative 15 times 1 is indeed 15. You can check all these by redistributing, like you've done distribution for years. You could check them all by distributing and you'll get back to where you started. Okay, this is how you factor by finding the greatest common factor. Let's dive into the practice problems. Let me know if you have any questions. You got this.